Good morning, everyone. We are here at the day 4 of the training, and today we'll be talking about how to test some of the functionalities that are being offered through payment building blocks implementation. So we can start with this. Yeah. So as always, this training is targeted towards the technical project managers, the implementation leads, and people who would be testing out the functionality so that they could have an understanding of what we expect when the features are being uh, tested out and they are being run, what to expect as the inputs and the outputs so that they would be able to test it properly. And we expect that the attendees would have the basic understanding of the govstack initiative itself, so as to understand the reason behind this entire project. You will also have some basic understanding of the G2P and P2G payment scenarios, so as to understand the functionalities better. Again, have some basic understanding of Kubernetes and containerized applications, as well as the CI/CD pipelines and understanding of the testing tools. So just to give you an idea where we are at, we've had 3 sessions so far. So today we are here at the testing of the Payment Hub implementation. So far now we have talked about that the Payment Hub has been implemented, has been set up at your end, and now you want to test out whether, and it has been properly configured as well, and now you want to test out how the transactions that we are talking about, the features that we are talking out, would be tested, or what we should expect when one of the transaction, one of the use case scenario is implemented. Again, a note on the terminologies that we'll be using. So whenever we talk about the payment building block, it refers to the payment building block working group's expectations around the functionalities that should be there in the candidate solution. And payment hub is the actual candidate solution over which the payment building block requirements have been implemented. So the scope of the training outlines, just to give you an overview, to showcase the G2P and the P2G use cases that the participants have, we would discuss them in a little bit more detail to explain what inputs need to be provided for initiating a certain process, and when that process has occurred or is occurring, what to expect as the outputs. We could also have a in greater details a walkthrough of the APIs that we have, and we could discuss the inputs and outputs and when those APIs would be used and why they would be used. So we would also be talking briefly about, let's say, if the system has been set up in the demo environment, how it could be configured as a mock ecosystem, so to speak, so that the transactions could be tested on them. And then we'll round it off with walking you through briefly through the possible test cases that could be implemented, the ones that we during implementation also tested out, and these are as suggestions to the implementers as well if they want to test out the functionalities. At the end of the training, we expect that you would have a better understanding or a more thorough understanding of the use case scenarios that have been implemented and when they are used and why they are used, and what are the prerequisites to them being functional and what purpose do they serve. And also, you would have some better idea of the possible options to test out the situations, these transactions and implementations, because there are multiple ways to do that. And also at the end of it, we expect that you would have a better understanding of the various APIs that have been made in to implement these functionalities. All right. So the first thing that we wanted to talk about, just to give a basic overview of the use cases that we have for the G2B, we will be talking about beneficiary onboarding, the bulk payments, primarily voucher creation, voucher activation. We would also be talking about voucher redemption briefly and give you an idea of how that could be tested. All right. So we also wanted to make a note over here that in the scope of testing, the customer experience, the end user customer experience has not been factored in because that is out of scope. But wherever we are referring to the customer doing something or entering in value, that is related to the understanding between the FSP and the customers themselves. All right. So, talking about the scenarios that we'll be talking about, first of all, the beneficiary onboarding scenario. Over here, it is important to note that this the beneficiary onboarding scenario would be a continuation of some prerequisite scenario where some source building block or a registration building block specifically would have registered a beneficiary in their system and shared those information and has to share that information with the payment building block so that they could keep that information in the in the identity account mapper and whenever any call comes in through which the beneficiary has to be made some payments, they could extract that particular information through the account lookup service of the payment hub and send it ahead. So the beneficiary onboarding registration is the prerequisite to any transaction related to bulk disbursements or or any sort of disbursements that could be made. So this feature enables the identity account mapper to store all the financial information of the beneficiary in the system. This is done through specific set of APIs that we have. And once this information is stored in the system, the other building blocks, whenever required, for example, health ministry, for example, education ministry, if they have set up certain programs, they could send in their bulk requests, their batch requests, payment requests to the payment hub. And because of the information stored in there, the information could be extracted and reused in the future. And also one thing important to note over here is, as we are going to show you, we have a couple of videos also to help you understand the processes better. The information that is stored in the identity account mapper also stores the modality, which we have also been talking about, that once the payments have to be made to the beneficiaries, through which form of payment they would be able to get the funds. Another scenario for G2P that we'll be talking about is the bulk payments. So this feature allows authorized users of external building blocks to create batches and send those requests for bulk payments to the payment hub. Now over here, we would also like to mention that for bulk payment, again, we have two sort of scenarios. The batches could either be created through an operations app that we have, a UI based we have, or directly through the APIs that there are there. So the external entities, external building blocks could send these requests, and they would be handled by the bulk processor within the payment hub to break them into smaller batches, then get verification on the amount, and then send the request to the payer FSP to roll out those batches accordingly. And this is what we'll be talking about going forward. We would also be talking about the voucher creation scenario. So voucher creation scenario, again, it has some prerequisites which we'll see going forward and which we've also discussed previously as well. Because of during this scenario, the source building block, it also ensures that it has provisioned sufficient funds within the payer FSP account from where those vouchers would be eventually redeemed, and that amount is also communicated to the payment building block, the voucher engine within the payment hub, so that once the voucher request comes in, that amount, it is checked whether the amount matches for the voucher creation request, and those vouchers are then eventually created. So there are a set of validations that are performed at the end of the voucher engine. And another thing, when we come to the next scenario, which is important to note over here, is that once voucher creation requests are sent to the voucher engine, they are by default created in an inactive state. So and what inactive state means is that at that point of time, once the vouchers have been created, they may or may not have been issued or allocated to certain beneficiaries, because and we'll see that functional IDs are optional at that time. They're matching with the specific beneficiary is optional at that time. However, whether they have been allocated to certain beneficiaries or not, the vouchers would be created in an inactive state by default. So before they could be activated, or before they could be actually used or redeemed, they have to be activated. So we'll look at quickly at the voucher activation API, that call that we send and activate the vouchers. Finally, once the vouchers have been activated, the other scenario is that vouchers are actually redeemed. So again, for voucher redemption, there could be multiple ways through which to test it, but we'll look at a particular scenario. For example, when someone goes to an agent and tries to redeem a voucher. So we'll talk about that. Those were the G2P scenarios, the government to payment scenarios that have been implemented and we'll be talking about. And then we'll be talking about the API implementations that have been done for the person to government payment, particularly the bill payment scenarios. So we have, first of all, we have two types of bill payment options. The first one that we'll be talking about is the bill payment through push payment. And this bill payment particularly involves the bill inquiry call as well. So we'll look at the scenario that how a bill inquiry is initiated through a payer DFSP, how that inquiry goes to the biller or aggregator via the payment hub through the bill pay module that we have, and how it returns the bill inquiry. And once the bill inquiry has been received, it depends upon the end customer of the payer FSP, whether they want to go ahead with paying the bill or not. And if they pay it, then how they communicate with the biller or an aggregator that the bill has been paid, and what role the payment hub plays in that. So this is a continuation. We've just talked about it. I'm sorry, this is actually related to the other part that we have. The other scenario that we have for P2G is bill payment through request to pay notification. In this scenario, APIs have been made through which a biller or an aggregator can send a request to pay a notification to an end customer through the payment hub itself. Now, there in the APIs that have been implemented, there are again two further options provided, which would be tested. It could either be that the RTP notification is sent directly through to a payer's account number, or it could be sent through by sharing an proxy or an alias. In both of the cases, the way the transaction progresses is different, and that we'll talk about. And you will see that we have various test cases for that. All right. We also wanted to highlight over here, these are the suggested tools if the implementers would want to test the functionalities. These are also the tools that were used during the implementation of this project. And the suggested type of testing that is recommended at the implementers end for particularly testing out these use cases is the functional testing, to see what are the inputs, what inputs are given and what outputs come out of that. All right, continuing on that, what sort of testing was done during the implementation of this entire project? We did various testing. So the basic ones we have listed over here. We did the component testing. Once each component was tested, then we went ahead with the integration testing. And then we also did some end-to-end testing using the mocks that we had. And all the tests that have been done so far, we have the test results for them over here on the official govstack page. So we've already shared the link to it. And if we want, we could go through, whenever the implementers want, they could go through these test results and see how they have been performed against the tests. So we have all of the tests that were, and this also ties up with what we were discussing yesterday in our call of the deployment channels. So all of these tests have been written in Cucumber, and those have been loaded into this CI/CD pipeline. And whenever a new test comes in or an update is made, automatically that pipeline is triggered and they are retested, and then those results are shared. All right. So we were talking about the scenarios that have been implemented for the use cases, and we talked about going into a bit more detail about them. Right now, what we'll do is that we're going to go into the details of each scenario, and at the end of it, we could open up the APIs and go through each and every field if we want. So first scenario that we'll be talking about is the beneficiary onboarding scenario. So beneficiary onboarding is the scenario of the use of government to person payment. So the direction it takes is it actually originates or starts from the registration building block and goes towards the identity account mapper. An identity account mapper then performs the processes of validating it, and if it's valid, then it sends a positive response. If it's not valid, then that is rejected, and the rejection report is sent via the APIs back. The service in question over here is the identity account mapper. So this beneficiary onboarding is primarily targeted towards identity account mapper service of the payment building block in Payment Hub. The expected inputs from this is that once the beneficiary onboarding batch or list is sent towards identity account mapper, it should include the functional IDs. Functional IDs are those IDs that have been allotted to the beneficiaries at the time of their being registered into the whole ecosystem of the govstack or an e-government. And for that functional ID, what program IDs are applicable to that beneficiary, then further information of the beneficiary, as well as the financial information of the beneficiary, so that it could be stored in the uh, payment building block in the identity account mapper. If everything is correct, all the information is, so some of the validation checks that are done over here is that the identity account mapper checks that the functional ID is unique, that it is not duplicated, because if a functional ID already exists in the system, it will reject that particular record. It will not register it. So once all of these checks are made, the expected output from this cycle is that once this feature is successfully utilized, it would return this. It would return the request ID of the original request. So when the call comes from a registration building block, when they call the particular API to onboard the beneficiary, it sends a request ID specific so that it identifies which request was come, which particular batch this request belongs to. The output of this would also include, the response would include the number of failed cases. So it will not, if a record is successfully validated and created in the identity account mapper, then that is not responded back into the responding API. However, if it just creates a report of all the cases that failed, it shares the number of it, and then it also shares their details in the array. And we'll see that this is included in the API body. Next scenario that we'll be talking about is the voucher creation. Again, this belongs to the government to payment use case. This is, again, it could be, this is initiated from a source building block. In our case, it could be there's another alternate option. This could be initiated through any acquirer FSP or an agent FSP. and it is sent towards voucher engine. Of course, what we are not showing over here is, in which we talked about in our earlier sessions as well, before the request reaches the voucher engine or the payment hub itself, there are multiple layers through which they pass. The request could be coming through various connectors, or it could, even if it's coming through a source building, or it could be hopping over the information mediator building block, then it passes the ingress controllers, and then eventually it reaches the particular microservice of the payment hub. But for the sake of simplicity, we are not mentioning those here. So the microservice in question here, the component in question here, which is key over here, is the voucher engine. Before voucher creation could be done, these are the main parameters that is expected from the API. It needs an instruction ID so as to identify the particular instructions for that voucher creation. It requires a voucher group code so that the system can identify which particular voucher request, which group those list of vouchers that have been requested are being created from, the currency in which the voucher is being created, the amount for the voucher that is being created. And this is where we are also talking about when we said that the prerequisite of voucher creation is that sufficient funds are provisioned in the account and that payment hub knows it. So payment hub would make a validation over here whether the amount is sufficient for voucher creation or not. Then we have payee functional ID. This parameter is very important because it maps particular voucher to a particular beneficiary. So it lets the system knows that yes, this voucher has been issued to this particular person. And we have narration. Narration is any explanation that we want to attach to the voucher. So upon the completion of this functionality, once all the checks have been done, and if everything is correct, one thing is to note over here is that we've been talking about previously also, when voucher creation request comes, it works in an atomic sort of way. So if the batch has any one record that is not correct, then the entire batch would be rejected. So it's an all or none request. If all the information is correct, then the system creates the vouchers and returns the response. So in the return response, the callback API, it sends the following information. It sends the instruction ID against each request. Then it sends the serial number for the list of vouchers and the specific voucher number so that they could be identified. All of this information persists in the voucher engine so that next time when a request for voucher redemption or activation comes, the voucher engine could check the status against it and perform the process accordingly. And other information such as the currency and the amount, this is echoed from the incoming request so that this is what is included. So obviously what we've written over here are the main parameters that are returned in the callback API, but there are other parameters as well. When we talk about voucher activation, this is the next logical step of after creation. What is important over here is that it expects the serial number. So over here, David, please jump in also just to explain it further. One check that has been implemented over here is the importance of the secret voucher number, which is not to be revealed. So what happens is when we're sending voucher activation request, we send the serial number and the system identifies the particular voucher from that serial number and activates it. So the thing that happens is either that voucher is activated or that voucher is not activated. So in the callback API, when it sends the status back, it sends the serial number for the voucher that has been activated. And if in case it has failed, then it sends the failure reason. David, would you like to add something over here or we could proceed?
I think proceed on. I think that's covered it.
All right. And we'll show you these steps shortly. But this is a video that would show you how you can see voucher activation in action.
Okay, let's start from here. Um, we have already integrated the key clock service that yesterday you have shared me. So, for instance, here, if I type any user, obviously I cannot have access for this because currently we have an integration and we cannot pass to the other section if we are not able to log on with the proper credential passing the key clock login process. Okay, so once time that I have been logged as we have now, even here appears my user. In this case, I created in the key clock environment user named operations, and the user for now has the admin role. That means that he will take in access for different sections here in general. Okay. Okay. Let's start first with the management here. So here we have the options to review the different beneficiaries that we have in the system, right? We have mainly this data, I mean, the government entity, financial institution, functional ID, financial address, and the payment modality uh, based on the um, ID and the more readable value in this case for 0 for mobile money, and we have around other four more for payment methods here. Okay, then we have this part for vouchers. Okay, the vouchers is a set of instructions that I can send to the backend services. In this part, very similar we have in the account management. In this first part, we will able to see the current vouchers that we have in the system for now. I mean, with this data, serial number, the vouchers mean when this voucher was added to the system, based maybe with the API or maybe with this option that we will review, creating a voucher, government entity, functional ID, and the status of this request. I mean, we could have some inactive, active, cancelled status mainly for these vouchers in general here. So this is just for query the information that we have related for vouchers. Well, let me go here. Okay. Um, from the create vouchers part, is one of the two sections that we have this option to upload a file with some specific layout. The layout can be downloaded by the user if they have not this on hand. They can click this download template. This this template is downloaded locally and maybe they can to upload to some cloud or maybe process this with some other spreadsheet tool like Excel or other similar tools
Hmm.
uh, and fill it this file has this structure as I will show you here, right? In the case for vouchers, we have 7 columns. The 7 columns are institution ID, voucher group, currency, amount of this transaction or instruction, sorry, expire pay function, functional ID, and narration that works as kind of description of this individual instruction. So these are some sample files here. So that is in general how looks this template for this voucher part. Okay, so how I can proceed with this? Practically, I can drag and drop the file on this area, or I can browse the file in this case, and the file is presented here uh, because the user will be able to review it in a preview way to be able to present the data that exists in this file. The process needs to have two other inputs apart of the data presented on the file. We have the request ID. The request ID is a random number generated by the system now, but if the user wants to input a different value here, he will be able to add it. Okay. And the second data is to use a URL for callback. The callback, as we know, is a way that the different backend services has to communicate the progress of the result of this batch or bulk process. Okay, if the user does not want or is not the right file uploaded previously here, he has the option that clear the data and go back to the previous view and reload the file that he needs to upload. Okay.
So here what we'll do is create a new file with specific values for vouchers and then upload it into the portal so we can see these uploaded and the new vouchers created.
Okay, we have here these three. And I will send this. We have the success here. That works. Okay. So based on that, we have covered now the vouchers and create vouchers in a bulk import way.
I think one of the key bits just to explain there, where it's doing it through the UI, it's still using the APIs underneath it. So all the UI is doing is giving a way to actually send that into the APIs. It's not a second backdoor API created for the front end. It's using the real APIs. So you can use that to test that the system is implemented correctly even before you've integrated effectively a source building block.
Yeah. So yeah, it's just David mentioned once you click on the create voucher button, it calls the create voucher API. Yes. Now we come to the final scenario of the voucher series. That is voucher redemption. All right, before voucher redemption could occur, we have talked about that it has to be created and activated. And there are again certain checks that are performed over here. But just to proceed with it, here we have written the way through which voucher redemption could actually occur. It could occur from the agent Agent could initiate it through any sort of, let's say, interface that they may have. This request, that interface could be given by an agent financial institution, and they could initiate the request, send in some of the inputs that we'll be talking about recently, and that agent FI sends this request to the voucher engine. So and that request could reach the voucher engine through the multiple connectors that Payment Hub provides, depending upon the type of request. So the expected input is that before voucher redemption could occur, of course, it requires the request ID, then it requires the voucher serial number, and it also requires this agent ID. It could be, again, a design decision, how agent IDs are allocated based upon that whole system in which the agents are registered, to identify them in the system. And finally, because we want to ensure that there's proper secrecy maintained and proper valid authentic voucher is coming in, so there is the second number, voucher secret number, that only the customer has, and they provide the agent. And so as a combination, all of this information goes to the voucher engine, which validates it, which also checks the status of the voucher, which we talked about, whether the voucher is active. Besides being active, the voucher could also have been expired. That is one of the input we did not specifically mention, but you will see about there is an expiry date attached to the voucher as well. The voucher engine checks whether the voucher is valid, active, it is not expired or cancelled. So we also have an API call through which vouchers that were once created, they could be cancelled if the source building block so requires. So for example, maybe multiple vouchers were created for a program that was then later discontinued. So we give that capability to the source building block to send out a request for voucher cancellation, and that vouchers would be cancelled from the Payment Hub's sources. And if a request comes to redeem them, then it would ensure that those vouchers are not redeemed. So one thing important to note over here is that the previous calls that we have been talking about, they're mostly asynchronous API calls. However, in the case of voucher redemption, this is a synchronous API call, which directly goes to the voucher engine. Voucher engine directly responds to the pair FSP via the connector that comes into play. And why this is done? This is particularly done because if, let's say, a beneficiary or an end user comes to an agent to redeem a voucher, they would not stand around waiting whether they are going to get a positive response or a negative response. So that's why, particularly for that reason, has been made as a synchronous call. So if the voucher is redeemable, then the voucher engine updates the agent merchant FI with the following information. It tells the status of the voucher, it echoes back the serial number, it echoes that this is the value of the voucher that has been redeemed. It sends the timestamp so as to maintain proper record when that voucher was redeemed, also to match that expiry date and the time when the voucher was redeemed. They did not by any mistake were different, or it is within the bounds. All of these information for auditing purposes later on, and the transaction ID. We now come to we've been through the voucher creation and voucher redemption and voucher activation scenarios. Now we come to the bulk payment scenarios. So bulk payment, again, this is a big call, and if we recall from our very first session when we had a walkthrough of the flow of this entire transaction, this involves multiple hops and multiple processes that occur within the payment building block. So a source building block sends a bulk payment request. Also, we have in the UI that has been implemented, we again provide an sort of a portal through which the the batches for bulk payment could be created and uploaded and then sent via the API to the backend, to the bulk processor for further processing. So again, there are multiple ways through which this bulk payment functionality could also be tested. So a source building block creates the batch and it sends to the payment hub, and the payment hub, once it receives the request into the bulk processor, it sends that request. This is just a recap of what we did previously. It sends the request to the identity account mapper to verify whether there are accounts that exist, information that exists against the functional IDs that have been sent. So the identity account mapper provides the specific functional financial information against the functional IDs. Then the bulk processor breaks those batches down into specific batches related to targeted towards particular FSPs, and then it communicates with its scheme connector. With scheme connector sends those requests ahead to the pair FSP to validate whether it has enough funds, sufficient funds to honor the transaction request. And then the pair FSP, the particular accounts, those accounts send back the responses. All of this information, for all of this communication that is occurring between the external factors and the payment hub, this is happening through the APIs that are there. And then if there are sufficient amount, then the request for is sent to the pair FSP to send out the actual transactions, send out the minimal, the small sub batches that have been done, and all that functionality is there. So the expected input, the main input, over here you see just two things over here. That is because when that source building block actually initiates that request, the main thing that is, and again we're writing out the main things over here, it sends us the functional IDs, a list that contains the functional IDs and the amount that has to be paid. It does not include any other information, because this is the point where we say that all that information related to where that information has to go, who are the beneficiaries financial information is all stored here within the identity account mapper, and all of those processes are the internal processes of the payment hub, and therefore the external building blocks, the source building block does not know. So this is how easy it makes it. And if we would get time, I'll show you the UI through the UI, that this is just the information that has to be given for a bulk payment. So what is the expected output once that request is received from a source building block? So as I just told you, I walked you quickly through the processes that occur once it receives the batches. It first validates the functional IDs, then fetches their financial address, then it breaks them into sub batches. It again requests for pre-authorization. Once it receives authorization, then it sends out the request to honor those transactions. So once all that process has been done, the payment building block sends back a callback, does a callback API, which updates about the statuses of the various sub batches that are done. And those statuses could, again, there are two options to that. Those statuses could either be seen on the UI that has been provided and the payment hub section of that UI, or if the integration has been done or there is a specific interface that a source building block has, that callback API could be targeted towards that, and it could show the status of the batches over there. So the callback API includes this information. It sends back a list which tells about the number of transactions that are still ongoing, that are still in the process. It sends the number of transactions that are completed and the amount that is for them. It also sends the number of failed transactions and amount. So this is the regular status callback API that the payment hub is going to push towards the requesting building block. Or this is or the payer FSP would send this back to the payment hub. However, there is another API which we would look at shortly, is that if this callback API does not come within the expected time frame, there is another API option that is given to the source building block, can call that API. It's the status update API, they could ask what is the status of the transactions. Also, another thing to note over here is when we're talking about this callback API, it just simply sends the stats of the transactions. It does not send any other particular information about those details of the transaction. So for that, we have another option available. Now, moving on towards the P2G scenarios that we have. First off is the bill payment via push payment, and this occurs through the bill inquiry sequence. This is applicable in scenarios, for example, in jurisdictions where, let's say, a utility company, for example, let's say an electricity company, distributes the bill invoice numbers. And important thing to note over here is for the implementation purpose for going forward is that the way system is designed is such that it is agnostic to whether the billing company is an individual biller, whether it is an aggregator of billers, or whether it is a bill payment system itself. So what essentially happens is that whoever is billing at the end, they need to get registered in the bill pay service of the payment hub. They are allocated a certain identifier, or which is sort of a prefix which has to be added. That prefix could either be uh, hard coded into the payer FSP's applications. It could either be requested for the customers to type in before sending the bill payment. But what it could be coming from, it could be handled in any of the ways. But once that is added, the payment hub is able to identify that the bill inquiry request is coming for which biller or aggregator or bill payment system, and it forwards it accordingly. Another point to mention over here, which is important, is that the payment hub itself, the bill module itself, does not contain any billing information. It is working in the capacity of receiving the request and forwarding it to the targeted system. Excuse me. So the microservice in question is bill pay, which is we have seen this module also in our previous sessions as well. The expected input, I'll show you. It is written down in the next slide. So it what it allows is, it allows the customers to initiate bill payment through bill inquiry. I'll go to the next slide first, just so you could see. The expected input for the bill inquiry request is the request ID, as always, because we need to identify the request, and the bill ID. This is a mandatory field, and this is crucial. And this is the number which consists of the invoice number or the bill number, receipt number, that has been generated by the billers. And this bill ID would include as a prefix, we've talked about it as a prefix of a few numbers, a few digits, which would identify the biller towards which this bill is intended. So the first input is, for the first call of bill inquiry, is request ID and bill ID. And to that, once that bill inquiry request reaches the payment hub, the bill pay service has a table through which it goes through and identifies the biller or the aggregator. Once it identifies the biller aggregator, it then forwards that bill inquiry request on that particular address, and then it is upon the biller or the aggregator itself to identify the particular consumer from that consumer number through that bill ID and return the following details for that bill. So this is an object that is returned as an object. Over here, the biller ID is again echoed from the request. The biller name is mandatory. The bill status is mandatory. Bill status identifies whether the bill is still unpaid or whether it's paid. It sends the due date, and then based on due date, these two are conditional outputs that it sends. It sends the amount which is applicable when it is within due date, and amount which would may be applicable after due date. So these are the conditional outputs that you would get. Once these outputs are generated and sent back to the payer FSP via the payment hub. Then comes the second step, in which it is upon the customer whether they would go ahead and pay the bill or not. So if they pay the bill, that is again, it happens, all that process occurs outside the scope of the payment hub. Payer FSP pays the bill, and we're assuming that the bill is paid by the consumer. Then it generates the next leg of this transaction, which is to let the biller or an aggregator know that my customer has already paid the bill. You should mark it as paid at your end as well. So for that, the expected inputs are bill inquiry request ID. This refers to the request ID that was part of the bill inquiry. So it echoes that, so that these two could be matched together in the logs, and they are there for reconciliation purposes. And then there is this payment reference ID. This is expected. So for the payer FSPs that would be onboarded, it would be required of them that every time they do pay a bill, a receipt number is generated, and that is sent as the input to the mark bill paid request as well, again for the purpose of maintaining for reconciliation purposes, so that the biller and also in case of, let's say, there are any disputes initiated at a later stage, this ID could be referenced over there so that they would have proof. So this information is sent as input to the payment hub. The bill pay service identifies it again. It sends this request ahead to the biller or the aggregator to request them to mark the bill as paid. Important point to note over here is that this second call to mark bill paid only occurs if the customer successfully paid the bill, and hence this payment reference ID has been generated. If the customer decides not to pay the bill, of course, the request is abandoned, or if the payment is not made, again, because this ID won't be generated, so this won't go ahead. So that's why it is very important, and that is why this functionality is implemented in Payment Hub, that this request of mark bill paid is sent as an advice. It works kind of like an advice and sent to the biller aggregator. And until a response is received from biller and biller or aggregator, this request keeps on being sent again and again. So this is one important thing. As an output, the biller aggregator receives the request and sends back as the callback API. It sends the following as the response. It sends the status, and the status could either be accepted or rejected. And in case if the status is rejected, it reflects the reason for that rejection. Now what we mean over here by rejection is that it could happen that someone other than the person who's paying the bill, someone else would have paid it. For some reason whatsoever, the biller could not accept this and therefore returns a rejection. And in case of rejection, returns it with the reason for rejection as well. All right, coming to the bill payment through the request to pay notification status. Now, this is in cases which is the request for bill payment is sent, and this happens usually in cases if we do not, in this case, bill inquiry is not coming into play, and the biller aggregator is directly requesting the end customer to pay the bill. And all of these calls are helped along by the Payment Hub bill pay module. So quickly to go through this, this is now in this scenario, as opposed to the one above. In the above scenario, through the push payment, the request was initiated through the payer FSP. In this scenario, the request is initiated by the billers or the aggregators themselves. So the biller aggregators have to be first again onboarded to the bill pay service, and they should be allowed to utilize this feature as well. This request is sent to the bill pay. They create an RTP notification, request to pay notification. And this request to pay notification could be done in two ways. It could either be directed directly towards a payer FSP's account, or it could be sent using an alias or a proxy for that pair. So in that case, the expected inputs for these are first and foremost important is the RTP ID that is generated for that request. then the bill ID to identify a specific bill for which the request is being made. The bill details have to be there. Now, since we do not have any bill inquiry in this process, all of this information is being sent by the biller and aggregator. Again, important thing to note over here is that none of this information is stored within the payment hub. And since it's the biller or aggregator generating the request, of course, they have that request, that information already stored. So they send the biller name, the amount that they are requesting for, and then the request type, whether it is a direct, it's routed direct towards the account or towards an RTP. So in case we in our RTP request API, we have the parameter which identifies whether it's directly to the account or alias. In case an alias is selected, then there is further parameter which identifies the type of alias that is being sent, so that it could be used to resolve the address. So the basic inputs that are expected from the RTP notification are these. Once that RTP notification is sent, the next steps that occur are that the payment hub receives it. If it is, let's say, we'll talk about this quickly. If it is an alias based request, then what it does is the bill pay module sends that request to, in our case, if let's say there is no, if the jurisdiction does not have any account lookup service already in place, then by default we provide the connectors to the Moja Loop account lookup service. So it sends this request to the account lookup service, to Moja Loop account lookup service, to the Oracle. It tries to resolve the address based upon the type of proxy that was sent, and it returns the financial address. Once that address is received, the request is pushed ahead by the payment building block towards the particular DFSP. The DFSP forwards that request to its user, and now it's upon the end customer whether to accept the RTP notification or reject it. So till now, no payment has been done, no financial transaction has actually occurred. If the end customer accepts the RTP request, or if it rejects the RTP request, that is communicated back to the biller aggregator through the same channel. The FSP returns the request, returns the response back to the payment hub, and payment hub gives the response back to the biller or the aggregator, and these are the information that have to be there. So it returns the RTP status, whether it has been accepted or rejected. Please note again at this point, and we emphasize this again, RTP acceptance does not mean that the payment has already been made as well, because that would come in the next slide, that could occur. And RTP, so if it accepts it or whether it rejects it. In case it rejects it, it sends the rejection reason in this field. Also, to further the capability, in case that response, the RTP notification response is not received, there is an RTP status API that can be called by the biller aggregator or the payment hub from the payer FSP to inquire about what happened to the RTP notification. So for that, RTP status request, things that are required, the input that is expected is this. We have not written over it. It sends the RTP ID in that case. It sends the specific ID so that status against that particular ID could be queried. And in response to that, the status ID, the status API returns any of these statuses. So in case the request has been accepted, it sends this. If the request is pending, which means the user has still not accepted or rejected it, whether that request has been expired, whether it was cancelled, or whether the request was rejected. So these are the statuses. All right. So we've gone through in some details of the processes of the scenario, the processes that are involved to implement the various scenarios. Now we are going to quickly also give you an alternate way of checking out these scenarios, whether these implementations are working properly or not. In that case, we'll be going through the setup that could be done. All right, so let's say we have all of these things in place, we have our demo environment ready, then we can set up a mock ecosystem through which we could fire the transactions and then see whether we are receiving the expected outcomes from that or not. So before that could be done, there are some prerequisite processes as well. The prerequisite processes are again that have to be set up in the mock form. For example, we have to ensure that some registry, we have to assume that some registry is already onboarded some beneficiaries, they are already in place. Even in real scenarios, in real world scenarios, before these things could be tested, it is important that there are already beneficiaries created, some amount has been provisioned in the treasury accounts or the payer accounts, and then the transactions could occur. So for the sake of validating these functional tests, some of the things that we would do in this mock setup is that we would set up some government entities, and I'll show you ahead how we do that. We set up some government entities, we have some payer DFSPs, we allot some account numbers to those payer DFSPs. All right, over here, again, just to emphasize this point, we're talking about a demo scenario, how to set that up and to check. Then each of those, then we should have some beneficiaries be set up, and each of those beneficiaries should be allocated some unique functional IDs. And then for those unique functional IDs, there should be specific account numbers. They could be in form of either account numbers, it could be mobile wallet numbers, and some program IDs should be created, or some programs should be set up. Just to give you an idea of this, we'll come to this visual later, but just to give you an idea of this, what we're talking about. So let's say we want to test up a scenario. We say that we have, let's say, two government entities. These could be two different ministries, let's say a Ministry of Health and a Ministry of Education, for example, which is over here. We're talking about, let's say, two ministries. To each of the two ministries, we allocate some ID. We have gov001 and we have gov002. Now, each of these ministries could have started two programs, and each of these programs would be given a certain program ID. So, for example, Ministry of Health could have started some social benefit program, for some maternity helping program. It could also have started out some childcare programs. So these are two different programs. For each of the program that is started, it has allocated a certain account from which it would pay, and it would have provisioned some funds in these accounts. And for each of these programs, they may have set up some beneficiaries, and each of these beneficiaries would have some unique functional IDs. These are the functional IDs that you see. And against these functional IDs, each could have various payment modalities. So for example, what is important to note is, again, this is coming back, circling to the point that Payment Hub provides that capability of interoperability. So it does not matter what is the end account, whether it's an account, whether it's a mobile money account, whether it belongs to Wakanda Payer FSP or it belongs to Venus Payer FSP, Payee FSP. It does not matter. What matters is that that information is here, and the Payment Hub would enable sending out that information to that. So this information, all of these could be set up in a mock account. We will be sharing this document as well, and we'll be sharing this information as well, how that could be set up and how this could then be tested. Now, how this would be tested is, before we start the actual testing, all of this information has to be in place. And when we have to test this information, what we do is, before starting this whole demo, we check the account balances in account. For example, for program one, we check how much balance is in this account, how much balance is in this account, how much balance is in this account. We also check the corresponding balances in the payee FSPs as well for the payee accounts. For example, each of these beneficiaries would have some account number that has been allocated to them for their particular account. Just to make this clear, for example, this payee FSP, this particular beneficiary has their account in the Wakanda FSP, which could also be the account for, let's say, the payer FSP as well. So it would have a particular specific account number allocated to it. We could, before we actually start the checking, it could be generated, those accounts could be viewed through, let's say, the Fineract app that they have. The beneficiary app opens up and sees the available balance in that. And similarly, through the UI that we provide, the payer, the government ministry authorized user could open up their Fineract app and see the account that the amount that they have in their payer account. Then they could initiate, let's say the government 001 employee initiates a bulk payment. How they do that? They do that through the interface that they have. They create a batch, they send a bulk payment request to the payment hub. Payment hub receives that request and let's say it selected all of these beneficiaries. And as you can see from over here, that all of these beneficiaries have payments that have to be made into various accounts. Two have accounts in the Wakanda bank. One that has to be sent as a mobile money wallet account, and one has payment that has to be sent to the Venus. So this means that once the bulk processor receives the request, it breaks them down into 3 sub batches over here. One sub batch would have 2 transactions. The other sub batches would have 1 transaction each. And once, if everything is okay, the validation is done, and there is sufficient money provided in this program one's account of the payer FSP in the Wakanda bank. It checks the amount, it says okay, and then it fires the transactions, and through the external network of payment network, that amount is received by the beneficiaries. Then what could be done is, again, that the beneficiaries could open their Fineract account, or they could open up their mobile money wallet and see how their balances have changed. So and once they see that, then similarly, the government employee could log into their account of their FSP and see how that balance has changed within their account as well. How, if it has gone down by the same number as it has gone up for the difference of the bulk transaction that they had sent out. Having said that, another thing to note over here is, since we provide the UI for this, the one that we just showed you in the video, there is the payment hub functionality in it. If you log into it, you would be able to see the batch that was sent out. It would also be able to see the sub batch that was sent out. And then you would also be able to see the transactions, and similarly, the status of those transactions. All right, so this is the information we've written down how you could set that up, just to check the functionality in a simulated sort of environment. All right, going forward, the process that I was just describing to you, again, we have written this down over here, so we're just going to pass through this quickly, but just to tell you about this process in a little bit more detail. So when we're talking about bulk payment functionality, we have some prerequisites that we've already talked about. It's very important that sufficient fund is provisioned so that those transactions could be honored. And same provisioning is communicated to the payment hub as well, so that it can perform the necessary validations. So as I just told you, the process that could happen is that an authorized person could log into a Fineract instance or any of their accounts UI and see how much amount that they do have. they could initiate it. This is the process that we've written down for you. So civil servant. Also, something worth mentioning over here is that this functionality could also be seen simulated in the sandbox environment, the demo environment that is up there on the govstack website. So you could also see that thing in action through the simulations that are already there for the unconditional social cash transfer as well. So civil servant logs into the registration building block UI, or they could log into the UI that is provided by the payment hub, and creates a batch, click pay for all the beneficiaries that they want to pay, and then they go in to the screen and check out the amount that they have. Once the transaction reaches the payment hub, it validates, it sends out, it goes through the entire process. And then, so what we are also looking at, probably if you're able to get a hand on some of the logs, and you could be able to see all that information through logs as well. So once the transaction received, which component goes to which microservice it calls, and how the whole process occurs. So just to give you an overview of the process, because this is the funds, our provision is a prerequisite which happens. Registration building blocks prepares that bulk batch for payment. It sends that to the payment building block. It receives it, the instructions. It debulks the batches, and then it checks whether it is all of those processes lie over here. It checks whether there is sufficient amount or not. It hands over the validated and authorized batches to the financial institutions, who send via their own scheme and switch all their own payment service providers. They disperse the actual payments and receive the beneficiaries receive the amount eventually. And over here, as a continuation, is that they call back the APIs and let the payment hub also know the status of the batches is there. So in this process, the APIs that are verified, if this if you send the proper input and you receive the proper output, as we've outlined earlier in the tables above, these are the APIs that have been verified through this process. So it is the bulk payment API, which is called for handing over a batch of bulk payment to the payment hub. This same API is also called by the payment hub when it is handing over a batch to the pair FSP. And then we've also verified the bulk payment status push. This is the callback API, which we talked about over here, that once a financial institution has been handed over and they've disbursed the payments, that this is with what they send back. They call back this API and let the payment hub know the status of the various sub batches. Excuse me. Also, this API get authorization has been verified. How? Because before the actual disbursement occurred, this process occurred in between, where the payment hub via the scheme connector sent this get authorization request to the financial institutions to verify whether the payer FSP had enough funds in it or not. Again, the payer FSP returned the get authorization response. If it was positive, only then the transaction had occurred. So if the transaction has occurred successfully, it means that it got the authorization response as well. And finally, it also verifies the batch details API, because this is something, if the source building block wants to know the details of what the transaction, then you could also see that through the UI that we provide. If you recall, we click on any transaction, double click on it, we can look at all the details of the transaction.
So this one covers how we can test voucher creation. So first of all, you need to make sure that there's sufficient funds available to allocate to the voucher. The second bit is to ensure that, when the vouchers are issued, they're not usable until they're in hands of the beneficiary. The same provisioning is communicated to payment BB, so it can maintain its own ledgers to validate if it can create the vouchers or not. The activation process obviously makes the voucher active, so they're created inactive as default, as we showed earlier, and hence therefore usable for the predefined use cases and a period of time if an expiry has been set. And the ministry can maintain and manage the list of vouchers either by going in and seeing that in the voucher, or they can obviously get a report off to do that as well. The initial process, this use case really defines how we create the vouchers into the voucher engine, because it's about payment request from an external BB, and that will be triggered when the source building block, such as the registration building block, initiates the voucher engine to create vouchers in the system. The implementers can test if the voucher creation is working as expected. So either they can go in the operations app, as we demonstrated in the video, click on the vouchers tab, create the voucher, etc. Or they could do it directly via the API. I think the important thing to note here is that webhook we saw in the video. So they can obviously use webhook site to see the data raw if they want to, or they could put in there if they're integrating into a voucher provider, i.e. someone who prints the vouchers or sets them as QR codes, they could actually put the integration URL in there, and that would send that file of data to the API of their integration partner to do it.
This is just the overview of the function of voucher creation, what we've just told you about. So voucher provisioning is done. This is the prerequisite process. It notifies the payment building block that this has been provisioned. Then the voucher life cycle starts. So this voucher life cycle, as we've talked about previously also, so first one is actually the voucher pre-activation, then it is activated, then it is redeemed. But in between, we have two other scenarios also. It could either be canceled or it could either be expired. So this is like 5 stages of a voucher that could occur. And again, this last part that we are showing over here, this is the outside the scope of the payment building block itself, but payment building block generates the logs and reports, which could be used for reconciliation purposes and for settlement by the payer FSPs. For the redemption process, we show right now, we show 2 methods through which it could occur. It could either be occurring through agents or eventually through merchants, when we will be talking about that use case. Again, since payment building block does not communicate directly with either agents or merchants, it would be doing so through their FSPs. So again, the way through which agents or merchants are onboarded to that system depends upon the system that they have over here, registration or aggregation system, acquiring system that may be in place at the end of the FSPs. So this just gives an overview of the entire voucher creation life cycle. The important point again to note over here is that if this process is successful, voucher IDs that are created would be reflected back and would be at the end of it. We had just added the few screenshots to enhance to explain the process, but we already had that video up. That's why we'll just skim through it. And this is because we were talking about, as we talked previously also, there are multiple ways to do it. Even if you do it right now, we were going through that how you could create vouchers through the operations app. But again, important thing to note over here is that also, okay, at the end of it, when the button of create send data was clicked, it calls upon the API. So the APIs that are verified through this process is the voucher pre-activation API, which takes input as we talked about above, and it also verifies the API create vouchers response API, because this is the callback API that returns that whether the voucher creation has been or not, and if it's not, it returns a reject freeze. So again, because we were talking about specificity, we are mentioning the Finact instances in the UI, but voucher activation again could be done through the API that we mentioned, the voucher activation API. Am I audible? Hello? Hello?
Yeah,
Hello?
we can hear you still. Yeah.
Okay, I'm sorry because it said the internet connection is not working. So the voucher activation API, I'll show you the API, and we've talked about the inputs that are sent to it and how this is done. Next, we come to the payment by voucher or the voucher redemption case that we are talking about specifically. So as we talked about, as we showed you the figure above, the voucher redemption case is applicable either through the agents or the merchant side, the acquirer side of it. They initiate the request, that request is sent to the payment hub, and it performs some validations, and then it is done. I'll show you the process, but some of the prerequisites are that have to be kept in mind is that valid vouchers exist already in the system, that and those vouchers have been allocated or issued to certain beneficiaries. So all that process has to be done before the vouchers could actually be redeemed, and there are enough funds present or in the account so that vouchers could be redeemed. So again, these are some of the steps that we assume if there was, let's say, an agent interface over there, so the agent could log into the system and then navigate to the voucher redemption section, enter the required information, which was related to the voucher serial number, the voucher secret number, and the other details related to the voucher, and it sends that information to the payment hub. So once that information reaches the payment hub, I'll just come to this first. So once that information, again, when we are talking about this, I've actually tried to, because we are talking about multiple ways through which this could be tested. That's why. So we're assuming that the voucher is created, the voucher is activated. There is already, if you are testing it in a demo environment, there's a sample payload which has these voucher serial number, agent ID, and voucher secret number, because these are the required inputs for voucher redemption. And the agent and the beneficiary is trying to get monies through the voucher, so that agent could initiate this request through this payload and sends the request ahead. Now this call, in a synchronous call, it goes to the payment hub, it reaches it through one of the connectors of the pair FSP. And then the voucher engine verifies if it is in a active status and it could be redeemed, and then it sends back a response whether it has been it is a failure or a success. So if it's a failure, it just simply sends the request and to the agent, and the transaction finishes over there. However, if the voucher redemption is a success, it notes that down into the log. It also lets the source building block or the voucher creation initial building block know that that voucher has been redeemed. All right. Besides that, there are also a voucher status API that could be called in case one doesn't know whether that voucher is applicable or not. They can call that API to know what status is the voucher in. So once that has been done, it would expected outcome is that the successful redemption of the test voucher is done, because we were talking about a demo environment, and that amount would eventually be, again, this is outside the scope of the payment hub itself, but whenever the settlement is done, as we showed you in the figure above as well, that settlement, the voucher engine generates reports and logs for the pair FSPs. They can reconcile them and do the settlement at their own convenience as per their own agreements. So the operations that are verified at this stage is voucher redemption API is verified. So if this voucher redemption call, when we successfully tested out the voucher redemption API, And we could also have had successfully tested a voucher status in case before sending the voucher redemption, we first entered the vouchers, we first call the voucher status API. And it could have resulted in any of these statuses. These are the main 5 statuses, but it could also have resulted in an error, which means that there was something not quite right with the voucher. Now, we are finally coming to the final set. These are actually just a set of suggested test cases that could be run at the implementer's end to test whether the functionalities that we've provided are working properly or not. And these were the tests based against which we have already showed you the results that have been uploaded to the official Atlassian page of govstack. So some of the things through which this could be tested, some of the positive API test cases. Again, all of these are for the API testing, the positive API test cases for the register beneficiary. And we're going to quickly skim through these and we could discuss them. This is just showing how we test each of these functionalities. So for testing positive cases of register beneficiary, it could be to register a single beneficiary with the payment modalities, because all of these payment modalities are allowed. We could test them with sending in these as payment modalities if they all, and these should all return a positive response because these are allowed. Then again, because we allow beneficiary registration in batches as well. So you could register multiple beneficiaries with payment modalities, all for bank account or mobile money account. And all of these should result in positive cases. These are some of the test cases when you are testing, because we talked about guiding you through creating a test plan once the payment hub has been implemented. So these are some of the suggestions that we give you. And these were also the tests that were carried out at the time of implementation at our end. Some of the negative test cases you could do for register beneficiary operation is that perhaps if you're trying to register, let's say 5 beneficiaries, but 4 come with valid registration institution ID, for example, and 1 with an invalid registration institution ID. Or it could be for other instances as well. Important thing to note for this particular first test is that before, as we have also been talking about all the prerequisites, before any building block or any FSP could communicate with the payment hub, it is essential that they are known to the payment hub and they are registered in the payment hub or configured in the payment hub. This reconciles with what we were discussing yesterday in implementation post-deployment configurations that we talked about, that each tenant that has to communicate with the payment hub has to be configured in the system. And they are each allocated their particular unique registration institution ID. So if that institution ID if some entity sends in a request and that institution ID is not registered in the system, that request would not be entertained. So if you're trying to register beneficiaries and the registration institution ID for 4 is fine, 1 is not, then when that one should be rejected, and a reason for that rejection would be sent back. So similarly, we could have like 5 beneficiaries and 4 would have valid format of functional ID and 1 would have 1 invalid. Then again, the 1 with invalid would be rejected. It could also be that 4 have not just the format, 4 have unique functional ID, 1 may have a functional ID that could have been a duplicate. So there are various ways through which this functionality could be tested as well. Again, for the payment modalities, 2 could be valid, 1 would be an invalid payment modality. Again, this depends upon which modalities are allowed in the system, which have been configured and which have been not. So these are some of the negative test cases that could be that could be loaded into the test plan that the implementers are trying to test the functionality of register beneficiary. Against them, we've just given you, just to give you some sample, again, we have all of this data, almost all of this data, in fact, in the test cases that we've shared, and that all of that is loaded into the Helm charts that we were talking about yesterday. So that is already there to be carried out and tested. So for example, for the positive test scenario, if we are trying to register a single beneficiary with payment modality is bank account, then the precondition would be that the institution is registered in the account mapper and that the pair FSP for the registered ISIN ID is configured in payment building block. This is the step that we're talking about. Once it has been set up, that registration institution has to be configured in the system. And expected outcome is that if this is correct, then that beneficiary would be created and you would be able to see it in the identity account mapper, for which one of the view, you just in the video that we shared, you could also see when we clicked on the identity account mapper, the account mapper tab, you could see one record over there. That could be that someone who was registered during the registered beneficiary. Similarly, we give an example of negative test scenario. If it is a negative test scenario, it could come with a failure reason, for example, invalid registration institution ID. And this coincides with the outcomes, the API that is returned after beneficiary onboarding. It contains the rejection reason if it's rejected. Similarly, we have some test cases for updating the information of the beneficiaries. There are various ways. Again, you could be testing out the formats, you could be testing out the input amount that is being sent, the IDs that are being sent. So all of these lists, these over here, we're going to pass through them because these are over here and we could go through them. And negative tends could be, for example, you're trying to update 10 beneficiaries. Again, we have an API for that. So it has successfully registered to an inactive account status, for example. So they could not be activated. They could not be updated. The information could not be updated, or they may have some invalid financial address, not in correct format in which this was sent, so they could not be updated. Because all of these validations are made before the actual registration at the identity account mapper. We give some examples. Now, we were previously talking particularly about the beneficiary onboarding or the beneficiary registration process. Let's come to some of the scenarios for the identity account mapper itself. So, for example, to test whether the identity account mapper is actually performing those registration processes or not, it's working as per expectations or not. So we could test it, the positive test cases that we recommend are, we could test whether a single beneficiary is being registered or not, whether payment modality is being updated there or not, whether account lookup is being performed for that identity account mapper or not. For example, this could be tested. Once you send a request with the functional ID in it, whether it is returning the correct response to it or not, that could be done. And some of the negative API test cases that we've listed down over here that could be tested is, again, that some beneficiaries may have inactive accounts, some may have some format issues. For example, you are sending in a functional ID that is not present in the identity account mapper, and it is still returning some information. So some of these are the scenarios that could be implemented and tested. We have given you, again, we have these test plan in place already. You could test it. So some of the preconditions are what I want to talk about before you could actually carry out these test plans. It is important that a demo CSV file for registering beneficiaries stored somewhere. You already have it, and you have the payment hub tenants configured. Again, as we said, that once the system is set up, it's very important that the correct configurations are made, correct data is there to perform functional or to perform the operations correctly. All right. So some of the negative test cases for bulk payment, if we talk about, there could be multiple negative bulk payment test cases. For example, the batch ID is not there, the format is not matching, I have to see that. I'm not matching. One of the examples, for example, that we've given over here is, let's say a batch contains 10 records, out of which 4 beneficiary account status is inactive, while 6 remaining beneficiary payments are processed because they have an active account. So one of the cases for bulk payment would be that a batch of 10 went out. And again, how we know this? We know this through the callback APIs that have been sent back. It updates the payment hub about the output of the transactions that were sent. But for that to happen, the preconditions are again that the request is coming from a registered institution. The batch matches the exact specifications. It is as per the template of the batch that we have, and then it returns the response. So for example, again, some of the examples is that the transaction sends a payload without any data or with incorrect data, for example, or the callback API, the URL for the callback API is not correct. So, or for example, sufficient amount is not present in the, or the incorrect functional IDs have been shared. So all of these could make up for the negative test cases when we are testing out that. So just to give you an overview of the API test cases for P2G, for example, bill inquiry request successful. The happy flow would be that all the information, the bill ID that is sent is correct. It contains the correct prefix for a registered biller or an aggregator. It would return correct response. It would return with details of the bill. So that would be a happy flow. The negative cases could be, for example, invalid. You send in an invalid prefix, invalid bill ID itself. For example, invalid bill ID would not be tested in the payment hub itself, because payment hub does not know one bill ID from another. It knows the prefix only. If the prefix is correct, it would send that request ahead to the biller and aggregator, and the biller or aggregator is unable to resolve that bill ID or find consumer against it, will send back a negative response. So these are some of the cases that could be set up for testing the bill inquiry functionality. And again, any request which is not sending in the bill ID, which is a mandatory field, it would be unsuccessful. The next leg of the bill payment is the bill payment notification, marked bill payment notification that is initiated by the payer FSP. So some of the successful test cases would be that a bill has been successful, it sends the correct payment reference number and in the format that is expected within the bounds, and it sends the correct bill inquiry ID. So it will be successful and it can send it onwards. Some of the negative test cases would be that it is missing any of the mandatory API inputs. For example, the request ID or the bill ID is empty, or maybe the payment reference ID is empty. Again, payment reference ID could not be empty because after all, this marked bill payment request is being done against a specific payment reference ID because it is required for, it may be required later for reconciliation purposes. Again, as we talked previously also, we have some preconditions, the preconditions being that the biller is registered in the system. The bill, before notification could occur, bill inquiry should have occurred. So right now, it's not, this would not be the case that directly marked the payer FSP and its customer paid a bill and then they just simply send this request. No, it would require a prior bill inquiry call to have been made. So positive request to pay is again the call that is made has all the fields valid in proper formats, and so you could test them that you are sending in the correct information, payload is being created and that correct API is sent and it returns proper. some of the preconditions for this is that the biller or an aggregator who is initiating the request, they are already onboarded to the payment hub and active for this functionality, for the RTP functionality. And that they have sufficient information, know the sufficient information that has to be sent. Some of the negative test cases, again, there are lots of them we have listed down, but some of them could be, for example, you can see from over here as well, the biller or FSP sends an incorrect BIC, for example, sends an incorrect bill account lookup, incorrect alias that is not configured in the system. It does not send the API in the correct format. For example, when we're asking for either to send the account number directly or the alias information, it sends both. It could corrupt, or for example, it does not select the type of request it is. So any of those cases could check negative RTP scenarios. Coming over to the vouchers for voucher creation, we have again for voucher creation, all the necessary information is there in the API. The mandatory fields are there within the correct format. That would be a happy flow. That would be easy to check. And also one prerequisite, we've been talking about preconditions. One prerequisite is again that sufficient funds are there before voucher could be actually created, and the payment hub and the account knows it. So all of these steps are there already written in the Circle CI as we talked about previously. And negative scenarios could be, for example, an invalid group code or a currency that is not supported. The amount is probably greater than what is provisioned for voucher creation, or it could be once the voucher is being created and functional ID is being sent with it. Again, this is an optional field, but if it is being sent, and then that one functional ID is not valid, does not exist in the system, that cannot be created because it could only be created for valid functional IDs. So for voucher activation, the one of the preconditions for voucher activation is that the voucher has to be created first, so that voucher serial number has to exist. And if it is there and all the mandatory information is provided, then that voucher would be activated. And let's say if a negative scenario for this would be, let's say, request for 5 voucher activation has been sent out. 4 of them are unsuccessful. Why? Because they were already active, already in an active state. One of them is only activated because that was inactive. So voucher activation API would only work if the vouchers were not previously in an active state, or maybe if they were not in a cancelled state or an expired state, only then they could be activated. All right, we have a voucher sent for cancellation, particular API to check for voucher cancellation. If it sends the correct voucher number, for example, if the API is loaded with the correct payload, then it would be a positive case. But the precondition for this is that the voucher can only be cancelled if either it was in an active or an inactive state, which means it wasn't previously cancelled already. Some of the negative test cases that could be tested out for voucher redemption are because they're invalid. They could be invalid because they were probably cancelled, they were expired. They could also not be redeemed if the agent or the merchant is not valid. Again, this process, it's part of the or the something that lies outside of the payment hub. It's more of an operational thing which would be handled at the end of the acquiring DSPs. They would have to create some form through which they could create agent database and allocate them agent IDs, and then ensure that that has been communicated to the payment building block also. So if if the request comes from any agent ID which the payment building block, the voucher engine does not recognize, it would reject it. All right. So, and if let's say some voucher has been cancelled and that request is sent, it is not identified by the payment hub, then they would not be redeemed and the request would be uh, rejected. Similarly, if the voucher is not in an active state, then it would be rejected.
Yeah. So the all the different test cases are here, namely based on the bill inquiry test cases. This is the happy scenario for the bill inquiry. This is happy scenario for bill payment, and then we have the test cases for the mock parts. So these two are the test cases for the mock part. I'll be demoing that. And then I'll move on to show the different negative scenario APIs. So starting from BI 00, RTP 001 is the uh, happy scenario test case for the request to pay, that is bill transfer request part. And then we have the negative test cases. So there are, I think so, 8 test cases in total for bill inquiry, the non-RTP part. And I think so there are 8 test cases in total for the RTP parts. So in total, I'll be demoing, I'll be just walking you through around 13 test cases. Oh, sure. So, moving on. So, this is this particular test case is an integrated test case that runs the bill inquiry for a particular bill ID with the payment part. So, it's doing both together. So, I'll just run this for now. And then after this, I'll move on to the mock bill API for the payments BB to biller aggregator and biller aggregator to payments BB parts. So as we can see, this test case was successful. I'll just show the logs here in order to show what the response had come. So this is the response for the bill inquiry that the transaction was successful, and we get the bill details of 001, the biller name, and etc. And then we have the same response that we got for the bill payments is what we are getting over here, that we are getting the ACK part, bill status acknowledgement. Yeah, so let me just try and run this test case for bill inquiry. Mm. Yeah, so as we can see, we successfully was able to call the mock API, and this is the transaction, the response. We get a successful transaction ID for this mock API. Later. But then moving on, I can show the negative scenario test cases one by one. So this is the bill inquiry test case where the bill inquiry fails due to invalid prefix. So I'll just run this test case one by one. So there are multiple test cases. As I mentioned, there are around 16 test cases for negative scenarios. The happy scenarios are what I'd shown you through Postman. So, and we have specific bill IDs that give us different responses for bill inquiry failures and all. So as we can see for this one, we got a response code error. So we expected that the request will reach payments BB, and from there, when we send the request to bill aggregator, there we'll get an error saying that the biller that was associated with this bill ID is not identified by us. So the biller did not identify the pair FI prefix. So that's why we have this error coming over here, that for bill ID 101, the biller was unidentified. And the reason that biller was unidentified, the pair FI did not match, was generally we expect a 00 here as the prefix for all identified billers in our current system. But this one was 101, so that's why it gave an unidentified biller issue. Moving on, the invalid bill says that the bill ID is invalid. The prefix is correct, but the ID that we have sent is not getting identified with the biller. So this is the test case for that, and I'll just run it. Yeah, so I extracted the non-empty response, and in this we are getting invalid bill ID as the issue because this particular bill ID is not registered with any biller. The biller is not able to identify this bill ID. So that's why we get the issue of bill ID. And this part, this error comes after we have accepted the request from Payments BB side. This error is generally coming from the biller aggregator side. Then FSP not onboarded will be an error that comes from the Payments BB side and not from the biller aggregator side. Because this FSP, the payer FI who is trying to initiate the transaction is not onboarded. So that's why we'll get this error from the Payments BB side. Yeah, so this is the response that I got, saying that the participant is not onboarded for this particular bill ID.
Right. One thing I just wanted to highlight over here in one of the negative cases, which was because of the time constraint, we've just put in a chunk of the video, where the bill ID was, the biller ID was not identified by the biller, that was, uh, uh, and in the way they later corrected it, it was actually handled at the payment hub end. So the payment hub, the bill pay service identifies whether it recognizes the biller prefix or not. So it is not handled at the bill ID. So if the prefix is not identified, then then the payment hub itself rejects that transaction at the onset. So just wanted to get this through. So coming to this at the end of it, and please also let me know if you would want. We've talked about the various APIs and the inputs and outputs that they want, but if required, we could also go into the document and go through the APIs and discuss their inputs and outputs if so required. But so far, just to summarize what we've done in this particular presentation is that we have gone through the what were the outcomes of the initial testing that was done on the payment building block during its implementation. We've shared those results with you. We've also talked about in a quite a bit of details of the scenarios that have been implemented for the P2G and G2P use cases, and what are their details, which service is invoked for them, which APIs are used, which processes are invoked for them, and what are the required inputs for them to yield certain outputs from them. So we've also looked at a way through which we could, for example, if we want to have an end-to-end testing of the system, how we could set up a mock system for that by creating some mock tenants, allocating them some budgets, and again, as a prerequisite to, we have to configure them in the payment hub instance that we've created in the deployment that we've done. But on the side for those instances, we have to allocate some funds to them and configure them in the payment system. Then we could start transactions from either from the UI that we have or through firing up through the Postman collection, API collection, or devise a mock payload and send that to the payment towards the payment building block, and then see the results in the corresponding accounts that we have, for example, through the FinRact or the mobile apps that we have. And finally, we talked about if the implementers want to chalk up their own testing plans for functional testing of the features, then what, as sort of a benchmark, what test cases they could use to uh, to set up their own test plans and test cases. So we are at the here now, the up next, the session that we envisage for tomorrow is we're going to walk through some of the reports and how to implement Kibana. Will talk a little bit about that, and then we are going to have a walkthrough of the services and warranty that is there, the regular level. So this is it, and then we come to questions.